Let's talk a little bit about decay series. Okay, here's what you need to know is if you start somewhere, okay, with uranium, say 238, what happens is uranium-238 will decay into an element that is radioactive, right? And that will in turn decay into something else that's radioactive, which will decay into something else that's radioactive. Pretty much when you get way up there in the chart of the nuclides, a lot of those things are radioactive, okay? So if you take a look at this number here, this is our atomic mass scale, right? So that is the A. This is our Z this way, right? Okay. So if you look at that, something that goes, notice that this is a difference of 4, right? Okay. So if you look at that, an alpha decay is one that goes down. It's Z minus 2 and A minus 4, right? That's got to be an alpha decay. So there's your alpha decay, right? And then little things that go this way, if the charge goes up, that's a regular beta minus decay, right? Which is just called a beta decay. If it goes this way, right, if something is going that way and the charge goes down, that's because you gave up a beta plus, right? Okay, so if you take a look at this thing, we start here and then we go to thorium, which beta decays, alpha decays. Some of these half-lives are big. That's 10 to the something years, right? The graphics here, something happened to it, right? But there's another beta, or I'm sorry, alpha. Then you get to this point. We get to lead, or I'm sorry, what is this guy? PO is that's element 83, is it? No. Yes, 84. 84 is polonium, of course, right? Neither a borrower nor a lender be, right? Okay. At this point, it just busts out, and it's like a road race that's not very carefully marked, right? Some people go this way, some people go that way. There's ways to predict what probability you have of going those ways. Notice that we're going to end up with, in all cases, the race ends at a stable element, right? So as soon as you get to a stable element, which will be lead 206, okay, you're going to go somehow from uranium-238, right, to lead 206, right? That's going to be the beginning and the end of this thing, right? So let's go do this. Let me just show you the coolest thing in the world, right? And I want you to go try this, okay? So let's go and find that. Where's that website? Okay, let's see. Which tab do I click on? There it is. Click on links, and then it is this guy right here. Okay, so let's find where is our, we want to start with uranium-238. Okay, uranium. Is that higher up on there? I think so. Let's find uranium. There it is, uranium-238. Okay, so let's find uranium-238. It's by the way, are there any stable isotopes of uranium? No. Yeah, they're all, it's just very few blue squares, right? Okay, so there's uranium-238, right? There's its alpha decay, right? If you want to, by the way, find out about that alpha decay, these are all the alpha decay goes down to there, and then these are gamma decays, right? Okay, but let's go, it goes to thorium-234, right? Okay, and then it does a beta decay, right? Another couple beta decays. Now we're uranium again, another alpha, right? Another alpha. Remember, there was a whole string of alphas, right? Okay, we're doing this guy here, right? We're doing this string of alpha. Eventually, it'll stop when we get to polonium, right? Okay, there we go. Now remember, this is the spot where it branches off, right? Okay, it's branching off where polonium, and there's an alpha possibility and a beta possibility. Well, I've done a lot of alphas, so let's do the beta one, right? And then another alpha beta. Let's do. Should we do alpha? Let's mix it up, right? Now, by the way, it doesn't matter. I'm just going to click on random things, right? Okay. We could click on that, but I don't think we should because that's really none of our bismuth. Okay, let's go to mercury and let's see. Let's go there. Oh, I don't want to click on that. Ooh, there's no places it doesn't, yeah, it's stable, right? I told you that we would get back to lead 206, right? So here's what you can do. Here's what you can do is you can go you can just go to the periodic, this nuclide table, right? You can go to that thing. Oh, whoa, let's go back. I don't want to go there. Oh my God, look at all the places we've been. My God, there it is. Okay, you can just click on any of these guys. It's not stable, right? And just, right? Electron capture. Electron capture. Oh, we're done, right? And that was a short decay series, right? So, by the way, electron capture is sort of the opposite of beta decay. It's like it eats one of its orbital electrons. Okay, we're done here.